Here we go. We have a question. Smallest window in a string containing all the characters of another string. So this question difficulty is marked as hard, but this question is easy because there's a hint in the title itself, window. So the concept we gonna apply is sliding window. So you have given two strings S and P, and we need to find the smallest window in a string S, in a string this containing all the characters including duplicate of string P. If the substring or the window is not found, if no such window exists, we need to return -1. So in case there are multiple windows, we need to return the window with the least starting index. So it is also mentioned that all the characters are in lowercase alphabets. So in this example, the smallest window is this. Actually, we need to include C. So this is the answer. But there is one another window which is this. But in this window, its starting index is greater than the previous window. So we returned this string. So that's how we have to solve this question. So let's build the approach. So I have taken the same test case. We have this P and this S, and it is also given that there are lowercase English alphabets. So we have an array of 26 length. So its last index will be 25. So one for P and one for S. 0 to 25. First, I will iterate and increment its position. So let's take T position is X, its Y position, then Z position. So T occurs one time, O occurs one time, and C occurs one time. So just for simplicity, I am taking T, O, and C instead of its integer representation. So if you are not familiar with, let me give you a gist. 0 for A, 1 for B, and 25 for Z. So that's how it will work. We just incremented, or we just count the frequency of each and every character. So there are 26 characters. Then it's time to iterate in this. First we have T. So I will mark T position 1, and we also have to take care whether we have found all the characters including duplicate present in P. So in this I, then we have I, then we have M, then we have E, then we have T again. So till now T again, then we have O, and then we have P and R, R, let's take R, then A, then C. So our first string I represents here and J represent to this position, and we have found A1, C1, and T2. So which is greater than or equal to this P, this P string, means we have found all the characters. So how to track if we have found all the characters or not? So one thing you can do is every time you can check whether there is a equality of all the characters, or if its character is greater, means there's t1 but there are t2, that's okay. Then o1, so o1 here, then we have c, so c1. So this is the point, this is the first string where we have found all the characters, so it's time to reduce the window. So it's time to increment our I. So then we increment our I. our window our window starts from I onwards. So I just incremented my I pointer. So now our window starts from here. So then we decrease the frequency of this t, because t is out of window. So now t frequency is decreased, so t is 1. So then we again check t1, o1 and c1. So still it is greater than or equal to this string, and this is the smallest window than the previous. So we take this window, because we also have to find the smallest window. So this can be our answer, but there's a optimized way. Instead of checking each and every character, there's a optimized way. What we do is we take a variable called find, and it tracks how many characters we have found till now. Initially it is 0. So let me iterate one more time. We take this string t, so t character increases. Now this t is less than or equal to, means this is the character that also present in this, means we have found one character that is present in string p. So we just need to increment our find. Then we have ai. So I is not there, I frequency is although 1, but I character is not present here, so we will not increment our find. So that's how it will work. M not increment, E not increment, T. So T frequency is 2 now, but it is greater than string pt, string p character t. It is greater than, means there's a extra character that is not present in p, so we will not increment, we will just ignore this character, like we have ignored I, M and E. So we don't need this character. Then we have o. So o is present in p, so we have o, and o frequency is increased, so we will increment our o also, we will increment our find variable also. Then we have p, r is not there, a not there, c. So we have found one more character. So our find value now becomes length of p. It means we have found all the characters present in string p. So it's time to reduce the window. So now our t is decremented by 1. So now t is 1, previously it is 2, now t is 1. It means it is still less than or equal to this, means we have removed a extra t, so that's not an issue. We have not removed any character that is also present in p. Then we have I. So we can remove our I frequency is reduced. Then we have m is also reduced. So let me use red pen here. So this frequency is also, m frequency is also reduced. Then we have e, we will reduce e. So till now we have this string, we have decreased our e, and we are good till here. Our I points here. So this is the first window. This is the window where everything is present in S is also present in string P. Means frequency of T is 1, frequency of O is 1, frequency of C is 1. So this is the first string. So we can take from I to J. Actually J is not inclusive, J is excluding, so we have to take J plus 1. Then first we remove this, so it affects our S. It means it affects our T. It means our T string is now reduced. T string is now reduced. It means we are losing a character that is present in string P. So now find is 2. Our find is 2. It is reduced. Our string starts from O till here. So our find is less than n, n means uh, length of P. So we need to include more characters. So this is the first character. Now this is the first character, so we will increment this frequency. So this is the character that is also present in P, and its frequency is less than or equal to T, is less than or equal to, its frequency is less than or equal to string P character T. So we increment our find, means we have found one more character. So this is the point, from here till here. This is the point that our find value is equal to n. So we can take this string, but we have already taken a string whose length is equal to this string, but the previous answer index is smaller, so we will not update our answer. Then we again need to go actually we have to reduce our size because we have found this. Now it's time to reduce the size. So can we take this, can we remove our O? If we remove our O, it it will affect, and now our find is 2. So string is this PRACT, only C and T is there, O is not there. So we need to include more characters. So I frequency is increased, C frequency is increased. So we have considered all these string, and our answer is this, TOPRAC. This is our answer. So this is the answer string. If the answer is not found, we have to return -1 string. So that's about the approach. Let's code this. So we have two arrays of length 26, one for string P, one for string S. So first we iterate in P and count the frequencies of each and every character, and we need to convert it into integer. So if the character is A and I am subtracting from A, character A, so it will give us 0. So A is correspond to 0, B is correspond to 1, and Z is correspond to 25. So we have taken the frequencies of characters in string P. Then we have sliding window, start from the 0th index, and we iterate till the j uh, we iterate till j is less than sn. So this is string n. So we have to traverse in the full string, and we are incrementing our j. First we have to take the character C. If I have taken the character C and we have to increment its frequency in S array. After updating the frequency, we have to check if the frequency is less than or equal to the frequency of same character in string P. If it is less than or equal to, it means there is a character. This current character is also present in string P. So we are considering this character. We have found one character. So I am updating the find. So if the find is equal to the length of string P, means we have found the we have found all the characters. So after this, if the answer is empty, means this is the first string. This is the first string. So we need to take this string. As I have said, J is not inclusive. So we also need to include the jth character. So after this, we need to increment our I. Before this, first take the character and decrement the character I, because it is now getting out of the window. So if the this character, the ith character, is out of the window and the character is also present in string P, means we are losing a character. If we are losing a character, we have to decrement our find, then we increment our I. So that's how this algorithm will work. At the end, if this string is empty, we have to return -1, and else we have to return our answer. One thing I missed is this: if this is the first string, we are considering this. if the length if the length is smaller than the previous answer, then also we have to take this string, because it is given we have to find the smallest window. So till I from I till j we have a window, and if the length is smaller than the previous answer, we have to update our answer. So let's give it a try, and let's talk about time and space complexity. The time complexity in this case, we are using sliding window technique, and in the sliding window the time complexity is order of Sn, and the space complexity is constant here. So we have meet the expected time and space complexity. Code is given in the description box. If you guys have any doubt, feel free to ask in the comment section, and thank you all for watching.